Welcome to The Explainer. Today, we're taking a deep dive into an industry that literally touches every single one of our lives, yet, it operates largely out of sight. We're going to unpack the massive logistical and environmental engineering challenge that is modern waste management. We'll be highlighting exactly how these entities collect, store, dispose of, recycle, and treat some incredibly diverse waste forms. We're talking everything from everyday municipal solid waste to hazardous materials and even compostable organics. It's a seriously fascinating world, so let's just get right into it.
Okay, let's dive into this. We're tracing the supply chain of waste in 5 steps. First, the broader waste management ecosystem. Second, collection and fleet operations. Third, storage and landfill disposal. Fourth, treating hazardous waste. And finally, number 5, recycling and resource recovery.
Section 1, the waste management ecosystem. We've got to start by grasping the sheer scale and vertical integration of this whole industry. The major players here don't just pick up your trash. They provide this massive, interconnected range of services from the curb all the way to final recycling or energy generation.
Now, you might think trash is just, trash, but the industry actually categorizes the origin of waste very strictly into 4 customer bases: municipal, commercial, industrial, and residential. Interestingly enough, if your neighborhood gets its trash picked up through a city contract, that's actually classified as municipal, not residential. Actually, scratch the assumption that all home trash is residential, right? It's a really rigid classification system, but it completely drives the financial and sustainability metrics across the entire industry.
To actually serve those distinct customers, these companies manage a massive interconnected real estate footprint. We're talking about active and even closed landfills, sprawling transfer stations where all that waste is aggregated, specialized recycling and composting centers, and of course, industrial incinerators for waste to energy.
To put that sheer infrastructure into perspective, industry sustainability standards mandate tracking the total amount of materials managed. That means any discarded materials handled, whether they're treated or not. Guys, we are literally talking about millions of metric tons moving through this ecosystem every single year. It's a logistical ballet of staggering proportions just to handle what we as a society throw away. Which brings us perfectly to Section 2, collection and fleet operations. So let's hit the road and look at how this waste actually gets from the customer over to those specialized facilities.
Fueling these massive vehicle fleets is, for sure, one of the absolute heaviest costs in the business. But we're currently seeing a massive strategic shift away from traditional fossil fuels. Today, these fleets are aggressively adopting alternative power, things like natural gas, biodiesel, and even electricity. They're doing this to slash their life cycle greenhouse gas emissions and, frankly, to dodge some pretty heavy regulatory penalties.
So here is a rather sobering fact. Driving these massive vehicles and collecting waste is actually incredibly hazardous. It boasts higher fatality rates than most other sectors out there. Because of this, companies relentlessly track workforce health metrics like the Total Recordable Incident Rate, or TRIR for short, along with near-miss frequency. It's also a heavily unionized workforce, meaning these companies must carefully manage labor relations. Think about it. A single strike could literally leave city streets buried in garbage.
All right, moving on to Section 3, storage and landfill disposal. What exactly happens once that fleet safely drops off its load at the end of the line?
I want you to really think about this question for a second. What happens when rain mixes with millions of tons of decomposing waste in a landfill? It doesn't just magically disappear, right? It creates a highly complex environmental engineering challenge that requires constant, vigilant management.
The answer is leachate. It's this toxic liquid runoff that can severely contaminate soil and groundwater if it somehow escapes containment. When dangerous constituents are detected above baseline levels, these facilities have to jump into action immediately. They're drilling observation wells, pulling continuous samples, and running long-term groundwater monitoring just to ensure they aren't poisoning the surrounding environment. It's a huge undertaking. But hey, toxic liquids aren't the only byproduct here. Deep down inside the landfill, the anaerobic decomposition of everyday waste naturally generates methane, which is a remarkably potent greenhouse gas. Because regulators strictly cap these emissions, facilities have to invest heavily in active gas collection infrastructure. Once they collect that gas, it's either safely combusted with an open flare, or, even better, it's harnessed directly for power. And this brilliantly illustrates how the industry is basically transforming a toxic liability into a highly lucrative energy source. By tracking the total millions of British thermal units, or MMB2, which is just a standard measure of energy, of the landfill gas generated, we can actually see a huge shift. Facilities are increasingly using this processed gas to power their very own operations, or they're piping it out to be sold directly to the grid. Talk about a win-win.
Now let's pivot to Section 4, treating hazardous waste, because while municipal trash is one thing entirely, a distinct and highly specialized segment of this industry deals with dangerous industrial and medical byproducts. Under international legal frameworks like the Basel Convention, waste isn't deemed hazardous just because it looks dangerous. It actually has to display very specific, legally defined characteristics. We're talking ignitability, corrosivity, reactivity, or toxicity. Treating this specific material, which is often done through intense incineration, demands an entirely separate tier of safety protocols compared to your standard solid waste.
When you're incinerating hazardous waste, the biggest threat immediately shifts to the air. Regulators mandate the strict tracking of things like oxides of nitrogen, sulfur, and volatile organic compounds, or VOCs. And this tracking is absolutely vital, especially when you consider that many of these incinerators are located within just 5 kilometers of densely populated urban areas. That means this air quality data directly impacts the neighborhoods we live in and the very air we breathe.
This brings us to our final act, Section 5, Recycling and Resource Recovery. This right here is the true frontier of the industry. It's the pivot from merely burying our trash to actively mining it for value.
Let's see how this builds a totally new economic model. Contrast the traditional cradle-to-grave landfilling approach, where materials are basically just abandoned forever, with the cradle-to-cradle circular economy. True recycling, at least under industry standards, means taking solid or hazardous materials and returning them to an industrial process to be used as an effective substitute for virgin feedstock or commercial products. Basically, it's about replacing the need to extract new materials from the earth entirely. Companies track these resource recovery avenues obsessively. They measure the exact metric tons of material recycled, the amount processed as waste to energy, and the volume composted. And it's really worth noting here, true industrial composting isn't just letting food rot in a big pile out back. It's a highly controlled biological decomposition process, perfectly sanitized through extreme heat, which creates a stabilized product for agriculture.
One of the absolutely most lucrative frontiers in this circular economy is electronic waste, or e-waste. From shattered smartphones to clunky old laptops, companies are essentially urban mining this material. By physically separating and reclaiming incredibly valuable metals and industrial ingredients, waste management directly feeds high-tech manufacturing supply chains.
So I want to leave you with this final thought. Based on everything we've unpacked today, is waste management really just about dumping trash? Or is it a highly technical, stringently regulated environmental engineering challenge that is totally foundational to building a sustainable, circular economy? Honestly, the data makes the answer abundantly clear. Thank you so much for joining me on this explainer, and as always, keep questioning the systems that run our world.